This video is on graphs of polynomial functions. Recall from Algebra 1 that a polynomial is the sum or difference of monomials, and a monomial is a number, a variable, or the product of numbers and variables with whole number exponents. A polynomial function is a function that is defined by a polynomial written in terms of the variable x. So for example, f of x equals negative 3x cubed plus 2x squared minus 5x plus 1 is a polynomial function. The degree of a polynomial is the value of its largest exponent. The leading coefficient is the coefficient of the term with the greatest degree. And standard form of a polynomial arranges the terms by degree in descending numerical order. So here's a chart that shows how you can classify polynomials by degree and number of terms. So a polynomial can actually be of degree 0. We call that a constant, so that would be just a number without a variable. Recall that a number without a variable, this is 5. It's the same as 5 times x to the power of 0, because anything raised to the 0 power is equal to 1. It has one term, and a polynomial that has one term is called a monomial. If the degree is 1, in other words, if x is raised to the power of 1, it's a linear polynomial. In this case, this polynomial, x plus 4, has two terms, so it's called a binomial. If it's degree 2, it's called a quadratic, and it's going to have an x squared. And since this is just one term, it's called a monomial also. A polynomial of degree 3 is called a cubic. So for example, 4x to the third minus 2x squared plus x. So this is a cubic polynomial. It has three terms, and it's called a trinomial. A polynomial of degree 4 is called quartic, so it's going to have an x to the fourth power. And a polynomial of degree 5 will be called quintic, and it's going to have an x to the fifth power. So for example, negative x to the fifth plus 4x squared plus 2x plus 1. Notice that this has four terms. We don't have a word for a polynomial of four terms, so we just call it a polynomial of four terms. We also don't have a name for a polynomial beyond degree 5. So if you did have a polynomial that had an x to the sixth, we would say that it's a polynomial of degree 6. So let's take a look at an example here. So for this polynomial, 3x plus 2 minus 5x to the fourth plus 7x squared minus x cubed, we need to write it in standard form, identify its degree and leading coefficient, and then classify it, give it its name based on its degree and number of terms. So to write it in standard form, we want to rearrange the terms so that they are in descending the powers are in descending order. So my highest term with the highest degree is negative 5x to the fourth, so that one's going to come first. And then I need to see if I have any x to the third, so negative x to the third. And then x squared plus 7x squared plus 3x plus 2. So that would be standard form because my powers of x are in descending order. Its degree is 4. Its leading coefficient is the coefficient of x to the fourth, which is going to be negative 5. And this would be a quartic polynomial. This is classifying it by degree and number of terms. Quartic polynomial of 5 terms. Because it does have 5 terms, and I don't have a word for a 5-term polynomial. The degree and the sign of the leading coefficient can determine the end behavior of the graph. The end behavior is the direction of the graph at the far right and the far left. So in other words, what is happening to y as x gets very small or approaches negative infinity? What happens to y, or f of x, as x approaches positive infinity or it gets very large? So here's a little table that explains that. So if my leading coefficient is positive and the degree of the polynomial is even, so for example here we have y equals 4x to the fourth plus 6x cubed minus x. So my leading coefficient is a positive 4, my degree is an even number, and here's the notation that we use. we say that as x approaches negative infinity, in other words, as x gets very small, or if I'm looking kind of from the origin looking to the left, f of x, or y, approaches positive infinity. So as x is getting smaller, y is getting bigger. Now let's look at the positive x-axis. As x approaches positive infinity, as x is getting bigger, f of x, or y, is also approaching positive infinity. It's getting larger. So as x gets smaller, y gets larger. As x gets larger, y also gets larger. Now, if my leading coefficient is positive and the degree of the polynomial is odd, so for example, y equals x to the third, then as x approaches negative infinity, f of x approaches negative infinity. So as x gets smaller, y gets smaller. And as x approaches positive infinity, as x gets bigger, y also approaches positive infinity or gets larger. If my leading coefficient is negative, and this should be familiar from a quadratic graph. You know that if the leading coefficient of a quadratic graph is negative, then it opens downward like this. So here we have y equals negative x squared plus 2x. As x approaches negative infinity, as x gets smaller, y gets smaller. As x approaches positive infinity, f of x, or y, also gets smaller. And if my leading coefficient is negative, but my degree is odd, as in y equals negative x to the third plus 2x, as x gets smaller, y gets bigger. As x gets bigger, y gets smaller. So let's use this to determine the end behavior of the graph of y equals 3x to the fourth minus 2x cubed plus x minus 1. First of all, I notice that my leading coefficient is 3, so that means that my leading coefficient is going to be positive. And my degree is 4, which means that my degree is going to be even. So basically this graph is going to look something like this, or if it's a degree 4, sometimes they have a little loop in it, something like that. So my end behavior is as x approaches negative infinity, as x gets smaller, so that would be like this end here, this arrow here, f of x, or you could call it y, approaches positive infinity. And then as x approaches positive infinity, as x gets bigger, and that would be like this arrow here, you can see that f of x also approaches positive infinity. The degree of a polynomial function determines its shape and the maximum number of turning points of the graph. That is the place where the graph changes direction. The graph of a polynomial function with degree n has at most n minus 1 turning points. The graph of a polynomial function of an odd degree is going to have an even number of turning points, and the graph of a polynomial function of even degree is going to have an odd number of turning points. A function is said to be increasing on an interval that is between x values when the y values increase as the x values increase. So y is getting larger as x increases. A function is decreasing on an interval when the y values decrease as the x values increase. So let's take a look at an example here that's going to illustrate those 2 points. So we need to describe the shape of the graph of this cubic function, which is y equals negative x cubed plus 3x, and we need to include a description of its end behavior, its turning points, and its increasing and decreasing intervals. So let's start by talking about its end behavior. So as x approaches negative infinity, f of x approaches positive infinity. So that would be this right here. So as x is getting smaller, y is getting bigger. As x approaches positive infinity, f of x approaches negative infinity, and that would be this end down here. So as x is getting larger, y is getting smaller. That's my end behavior. This graph has, since this graph is of degree 3, it's going to have at most 2 turning points and those are going to be right here. So in other words, where does the graph go from going down to heading back up, and where does it go turn from going up to heading back down? So it looks like I have two turning points at -1, -2, and 1, +2. And what are my increasing and decreasing values? So f of x is increasing, or actually I called it y here, but f of x works also, is increasing on the interval from here to here. You can see that as I look at the graph going from left to right, it's actually going up. So at this point, x is -1 is less than or equal to x, which is less than or equal to 1. So that would be, actually, you know what, I'm not going to do or equal to, because I'm not going to, because actually at that point the graph is not changing, so I'm just going to do less than. So between -1 and 1, the graph is increasing, and f of x is decreasing. And that would be this part of the graph right here, and this part of the graph right here. So heading up to that point, decreasing on the interval when x is less than -1 and when x is greater than +1. So increasing on this interval right here and decreasing on this interval here and this interval here. And we express it as though it's almost like we were expressing an inequality on a number line. And the last thing we're going to take a look at is that if we are given a table of values of a polynomial function, we can determine its degree by looking at the consecutive differences of the y values. So what are the differences between the y values in the graph? If the first differences are constant, then the function is going to be linear. And then remember that that's part of how you figure out what the slope is, the change in y over the change in x. But if those first differences aren't constant, then we need to look at the second differences, and if those are constant, the function's quadratic. If the third differences are constant, then the function is cubic, and so on. So let's take a look at an example here. So I need to determine the degree of this polynomial function, and here I'm given a table of x and y values, and I guess what's important is that the change in x is constant. So now I need to take a look at my y differences. So the difference between -13 and 4, and actually we subtract, I guess you could subtract either way, but let's do -4 minus a -13 gives me a 9. -1 minus -4 gives me a 3, so I can already see that my differences are not constant. But we need to keep going here. So 2 minus a -1 gives me a 3, and then 11 minus 2 gives me 9, 32 minus 11 gives me 21, and 71 minus 32 gives me 39. So if these were the same, that would tell me that the graph is linear, that the polynomial function is linear, but they're not the same. So I need to look at, those are my first differences, so now I need to look at my second differences. So 3 minus 9 gives me -6. 3 minus 3 gives me 0, so those are not going to be constant, but we need to keep going. 9 minus 3 is 6. 21 minus 9 is 12. And 39 minus 21 is 18. If those had been the same, that would tell me that my graph is quadratic. My graph is not quadratic because those differences are not the same. Those are my second differences. Let's take a look at the third differences. So here I have 0 minus -6, which gives me a 6. Here I have 6 minus 0, which gives me a 6. Looking good. 12 minus 6 is also 6. 18 minus 12 is also 6. So here I have my differences are the same. And since those are my third differences, that tells me that this polynomial function is of degree 3, or it is a cubic function. So in this video, we took a look at the graphs of polynomial functions. We looked at degree and leading coefficient, how to name a polynomial based on its degree and the number of terms. We also took a look at what end behavior is and how to write that, turning points, increasing and decreasing variables, and given a table of values, how to determine the degree of a polynomial function.